A text chatbot can pause for 10 seconds, and it mostly just feels slow. A voice agent pauses for 10 seconds, and the conversation feels broken. That difference changes almost everything. Voice is real-time. It is interruptible. It carries timing, hesitation, emphasis, and social expectation. When you type to a chatbot, you expect a turn-based system. You send a message, it thinks, it replies. But when you talk to a voice agent, you expect conversation. You expect it to know when you are done speaking. You expect it to stop when you interrupt. You expect it to recover when you correct yourself. And you expect it to use tools without leaving you in awkward silence. That is why voice agents are not just chatbots with microphones attached. A real voice agent is a real-time operating layer. It has to listen, reason, act, remember, and respond under conversational pressure. The simple version looks like this. A microphone captures audio. A voice activity detector asks, "Is someone speaking?" An endpointing system asks, "Is the user done?" Then speech recognition turns audio into text, or a real-time audio model consumes the audio directly. After that, the agent loop takes over. The model reasons over the request. It may call tools. It may read memory. It may check permissions. Then the system generates speech and plays it back. So the pipeline is not just audio in, audio out. It is microphone, voice detection, turn detection, speech understanding, conversation state, model planning, tools, memory, safety, speech synthesis, and playback. Older systems often use speech to text, then an LLM, then text to speech. Newer systems use real-time multimodal or speech-to-speech models. Those can feel more natural, but they do not remove the hard parts. The application still needs state. It still needs tools. It still needs memory policy. It still needs observability. And it still needs to know what to do when the user interrupts. The model matters, but the experience comes from the loop around the model. The first major difference is latency. In text, latency is annoying. In voice, latency becomes part of the conversation. If a person asks you a simple question and you stare silently for 3 seconds, they do not just think you are slow, they wonder if you heard them. They may start repeating themselves. Voice agents have the same problem. And the delay is not one thing, it is a stack. The system has to capture audio, send it over the network, detect speech, decide when the user is done, transcribe or encode the audio, get the model to respond, maybe call a tool, synthesize speech, stream the audio back, and play it through the speaker. Every step adds time. That is why time to first token is not enough. For voice, the user cares about time from end of speech to first audible response. They also care about how quickly the agent stops when interrupted, and whether tools create awkward silences. A good voice agent does not just need to be right, it needs to be right soon enough that the human still feels like they are in a conversation. Endpointing is one of the hidden hard problems. Voice activity detection asks, "Is someone speaking?" Endpointing asks, "Is the user finished with their turn?" Those are not the same thing. Imagine the user says, "Can you book a flight from Chicago to," and then pauses. Are they done? Probably not. They are thinking of the destination. Now, imagine they say, "Move my meeting to Friday," and pause. Are they done? Maybe. Or maybe they are about to say, "But only if Sarah can attend." If the agent waits too long, the conversation feels dead. If it responds too early, it interrupts the user and acts on incomplete information. Simple systems use silence thresholds. But real speech is messier. People hesitate. They restart sentences. They say, "actually." They trail off. They speak with background noise. So production systems need more than a timer. They need semantic endpointing, adaptive thresholds, repair behavior, and sometimes push to talk. Endpointing is not just audio detection, it is conversation management. Now make the problem harder. The user interrupts while the agent is speaking. This is called barge-in, and it is essential for natural voice UX. Without it, the user gets trapped. The agent starts a long answer. The user realizes it misunderstood, and there is no graceful way to stop it. But interruption is not just stopping audio. The system has to detect user speech while assistant audio is playing. It has to avoid mistaking its own speaker output for the user's voice. It has to stop playback quickly, cancel pending speech, maybe cancel model generation, and update the conversation state. Then there is a subtler problem. What does the system remember? Suppose the agent says, "Your appointment is confirmed for Tuesday at Convenant," and the user interrupts, "Wait, not Tuesday." Did the appointment already get booked? Did the user hear the full sentence? Should the generated response stay in memory? Does the tool call need to be rolled back? A production voice agent has to separate what the model planned, what was sent to speech synthesis, what was actually played, what the user heard, and what actions were committed. If it gets that wrong, the conversation history drifts away from reality. Tool use is where voice agents become useful and fragile. A text agent can say, "I'll check that," run a tool, show logs, ask a clarifying question, and return a detailed result. A voice agent has to do that while maintaining conversational flow. Take a simple request. "Can you move my meeting?" and text Alex. The agent has to understand the request, check the calendar, identify the meeting, find available times, maybe ask for confirmation, draft the message, send it, and summarize what happened. Each tool call adds latency. Each tool result changes state. And each external action creates risk. If the calendar API is slow, does the agent stay silent? Does it say, "Let me check"? If the tool fails, can it recover naturally? If there are two Alexes, does it ask a short clarification? If moving the meeting affects other people, does it need explicit confirmation? This is conversational tool orchestration. Voice agents need short progress updates, but not fake filler. They need confirmations before irreversible actions. They need fallback paths when tools fail, and they need to speak critical details clearly: dates, names, prices, addresses, and commitments. The hard part is not calling the tool. The hard part is calling the tool without making the conversation collapse. Memory makes voice agents much more useful. A good voice agent can remember your routines, preferences, projects, names, calendar patterns, and the context of earlier conversations. That changes what you can say. You can say, "Move my usual Monday sync," and the agent knows what that means. You can say, "Remind me to follow up with her," and it knows who her is. You can say, "Use the same format as last time," and it remembers the format. But voice also makes memory riskier. People speak casually. The microphone may capture background speech. A family member may walk into the room. A customer may say a credit card number. A patient may describe symptoms. A child may talk to the device. So memory cannot mean store everything. A production voice agent needs filters. What is a stable preference? What is temporary context? What is sensitive data? What should be discarded? What requires consent? What can the user inspect and delete? Voice makes AI feel more personal. That makes memory more useful and more dangerous. This is why voice agent demos can be impressive and still not prove production readiness. A demo usually has one speaker, a clean microphone, a short task, a strong network connection, and a path where everything goes right. Production has background noise, accents, overlapping speakers, bad microphones, long pauses, slow tools, missing permissions, ambiguous names, users who interrupt, and users who ask for things the system should not do. The demo problem is, can it talk? The production problem is, can it keep talking when everything goes slightly wrong? That requires recovery. The agent has to handle bad endpointing, echo-triggered interruptions, speech recognition mistakes, slow APIs, failed tools, and state that changes mid-sentence. And debugging requires timing. If a text agent fails, you can inspect the prompt, response, and tool trace. If a voice agent fails, you need to know when the user started speaking, when VAD fired, what partial transcript existed, when the model started generating, when audio played, and when the interruption happened. If you cannot replay the timing of a failed voice session, you usually cannot debug it. So the real shift is not just better voices. The real shift is real-time agent runtimes. A serious voice agent system needs a real-time audio layer, a conversation state manager, an agent planner, a tool router, a memory system, a permission layer, a speech personality layer, and an evaluation harness. Each layer solves a different problem. The audio layer keeps the conversation fast. The state manager tracks listening, thinking, speaking, interruption, and repair. The planner decides what the agent is trying to do. The tool router connects it to external systems. The memory layer personalizes behavior without storing everything. The permission layer prevents unsafe actions. And the evaluation harness tests whether the whole system works in actual conversations. That last part matters. Voice agents cannot only be evaluated with single-turn prompts. They need tests for interruption, recovery, latency, tool failure, ambiguous speech, noisy environments, and long-running tasks. The important benchmark may not be whether the voice sounds human. It may be whether the agent can recover gracefully when the conversation goes off script. So, what should you watch as voice agents mature? First, end-to-end latency. Not just model latency, but end-of-speech to first audio. Second, interruption handling. Can the user stop the agent naturally, and does the system update state correctly afterward? Third, tool use. Can the agent call tools without awkward silence, fake filler, or unsafe side effects? Fourth, memory. Can the agent remember useful context without turning every conversation into a permanent recording? Fifth, deployment. Does it work only in clean demos, or also over phones, browsers, desktops, cars, smart home devices, and noisy rooms? Sixth, evaluation. Are we measuring real conversation quality, or just whether the voice sounds impressive? And seventh, privacy. As voice agents become more ambient, the question is not just what they can do, it is what they should hear, what they should store, and what they should forget. Voice agents are not just a new interface. They are where AI has to become fast, interruptible, stateful, useful, and trustworthy at the same time. That is why the field is moving beyond simple speech to text and text-to-speech wrappers. The real work is real-time orchestration, knowing when to listen, when to speak, when to wait, when to stop, when to call a tool, when to ask for confirmation, and what to remember afterward. A chatbot can be a document you talk to. A voice agent has to be something closer to a participant in a live system. So the future voice agent is not a chatbot that talks. It is an operating layer, something that listens, reasons, acts, remembers, and responds in real time. And that is what makes it powerful and hard.